So now we have the natural way we extend before we get into interaction is 2 factors, 2 nuisance factors instead of 1 nuisance factor, 2 nuisance factors. We can do it for n nuisance factors, we will talk about it. We do what is called as Q nuisance, that is by name Latin square design. This is called a Latin square design. Okay, there I have 2 nuisance factors, not just 1, 2 nuisance factors. So the Latin square design is used to eliminate 2 nuisance sources of variability. Okay, that is, it systematically allows blocking in 2 directions. Okay, the rows and columns actually represent 2 restrictions on randomization. Okay, so we have the rows and columns as blocks. Okay, we have 3 factors now. Okay, so we have rows, okay, rows, columns, and one more factor on top of it. So you look at this batch of raw materials. Okay, there are 5 batches, 1, 2, 3, 5, and then there are 5 operators. There are 5 batches, 5 operators. It is there you are interested in 2 factors. They are blocks for me. New blocks and treatment is what I am interested in. So still my null hypothesis will be on tau, only on 1 treatment. I have 2 nuisance factors. Okay, one way or another it is only 1 treatment, 1 factor which is of interest. Still I am interested in only in 1 factor, but I have 2 nuisance factors. So my nuisance factors instead of 1, it has become 2. You can do the same for 2 factors which is of interest. You can consider 2 factors as interest and 1 factor as nuisance, right. So this expands your possibilities. Earlier in RCBD we dealt with 2 factors. The 1 factor we called it as nuisance, but it could be not a nuisance, but it is also a factor of interest to you. Nobody is stopping that. Okay. Similarly, now we are able to handle 3 factors. Think of that way, you are able to handle 3 factors. Okay. Only thing is I have not considered so far as interactions. Okay, that I will deal at the end, towards the end. But now instead of 2, I am moving on to 3, and I will show you how to do 4, 5, etc. in single shot. Okay. Now we are moving on to 3 factors. In here what are the 3 factors? Raw material, operators, and this numbers A, B, C, D, E. Okay. So the entries have become rows, columns. This is like exactly your image. Your image, what is your image? How do you represent an image? How do you represent an image? Matrix. What is a matrix x, y, and what are the values? X is your x direction, y direction, and what is inside the matrix? Value, intensity. Exactly like this. So your rows are one, your rows are your 1 variable, 1 factor, columns is another factor, okay, columns, rows, and the entry is another factor like your intensity. That is how you embed 3 factors into the matrix itself. Earlier it was rows and columns, now the entry itself is a factor. Okay. So this is nothing but your Latin square design. Why, any reason why it is a square design? Why is it a square? I cannot have non-square design here. Imagine if I have more rows, then what will happen? If I have more rows, what will happen? The block, it will not be a B, C, D. Look at this, there is an interesting thing. A, B, C, D, E, 1 is complete. B, C, D, E, A, another. So each row has all the treatments of interest. If I do not do it that way, if repetitions are there, then I cannot compare. You see the problem? See, if I have A, B, C, D, E, again what will happen? A will come. if I put it as 6 whatever 6, then it will become B C D E A B. B will repeat 2 times in the second row, C will repeat 2 times in the third row, first row A will repeat 2 times. If I make 1 from deviation from square to non-square, you understand. So that is why it is a Latin square design, it is a inherently only a square design is allowed, okay. That is rows equals to columns equals to treatments. This is a specific square design, you should pick up the treatments, the nuisance and the rows, columns, everything has to match. I can replicate this square multiple times, meaning what, I finish this square, I do another set, I make another square, I make another square. For to answer your question, if I have if I can make it into multiple small whatever Latin squares and start working, but this should be a square design. If I do not have a square design, then the problem is the treatments repetitions will be different in each rows, and therefore you will not be essentially able to block the nuisances, you understand. So what happens, if you look at first row contains all treatment levels. Remember, when you want to block, what you should do, if you want to consider age as a factor, you have to give the same drug for across age groups, only then you can compare that across age groups, for 5 to 10, age group 0 to 10 it did not work, 10 to 20 it worked, 20 to 30, how can you do it? You should apply the same treatment to all the age groups, where age groups is your blocks. Now suppose if I do raw material is as a nuisance, the same raw material, the same treatment, look at this if A is my treatment, A should be in each batch, each. So operator 1 is using A, batch 1 is also using A, okay. And so look at this column wise also, all operators have used all the batches, row wise also all batches, all operators have used all treatment levels, all batches have used all treatment levels. Here A, B, C, D is my treatment levels, operators are the nuisances factor, one nuisance factor, batches is another nuisance factor. So each operator gets to work with all treatment levels, each batch has all treatment levels, same numbers. Now if I do not make it as a square, what will happen? Operator 1 may be exposed to one treatment twice, or he may not be exposed to all treatment levels if it is not a square design. So square design is a key, you understand, that is why it is called a Latin square design, okay. The name Latin comes from the wording and the symbols used, so it is a square design, clear. See, each column here is representing operators, different operators, working with the material. I am not saying age groups, operators, okay. Operator 1, see as I told you tailor, if you want to see the difference whether this machine is doing good or not, what you should do? If you have 4 tailors, each tailor should work on a old machine as well as on the new machine, otherwise how will you say one is better over the other? Then the tailor will influence the result, because one tailor may be an expert, one tailor may be a novice. Unless you expose the same tailor to both the machines, only then you can look at the difference between how he operated on the old machine versus how he operated. So similarly, operator is exposed to all treatments A, B, C, D, E, and raw material is also for all treatment levels. So raw material 1 has treatment A, B, C, D, E, only then you can say that the effect of treatment is not due to raw material or not due to operator, it is truly the effect, it is because of the treatment A. That is what we want to prove, okay. So this is your square design, and this is typically a square design, you cannot go for a non-square design here, okay. The moment you talk about 3 factors, especially it comes to a square design. You can create multiple smaller squares and compare, but still it has to be a square design. Okay. So you have 4 cross 4, 5 cross 5, 6 cross 6, etc. Okay. So remember, every row, the idea is every row and column should have exposed to same number of treatments, same levels of treatments, same number of levels. So now my model is going to be one more factor, alpha, beta, tau, alpha, beta and epsilon I, j, k. So you have tau I treatments, beta j is the kth column effect and alpha is the ith row effect. Okay. So you have rows, columns plus treatments, tau I, beta j, epsilon k. Notice ij does not no longer represent rows, columns. I is associated with treatment, j is associated with block, k is also associated with block. Okay. Alpha I, alpha, no, whatever, alpha I, tau j, beta k, whatever symbols you want to use. Okay. But now there are 3 factors that are considered into picture. So this is your Latin square model. Okay. So here again you should have expected, now the total sum square total is divided into rows, columns, treatments and errors. Rows and columns are blocks, or you can consider it as another variables, rows, columns, treatments and error. So you have 4 divisions. Okay. The idea behind all of this division is there are no interactions, keep that in mind. The treatments are not interacting with rows and rows and columns are not interacting with each other. Okay, that is the assumption. That is why I could simply split the sum square total into treatment, rows, columns and error. Okay, clean. So this is no interaction model. So next class we will actually solve this. I am not going to derive anything, I will show you an example and complete it, and we will move on to Greco-Latin square, which will the last part where I could have multiple factors. Okay, not just 1, 2, 3, you could have as many factors as you want. Okay, so that will be the pinnacle, meaning I would have covered any number of variables without interaction. After this we will move on to interactions. That is it. The interactions we will do 2 factorial and 3 factorial, 2 to the power 2 and 2 power 3 factorial experiments and then call it a day. Clear?